Let us consider a body of mass m moving with velocity v, and its kinetic energy is given by half mv square. So mass is scalar quantity and v square is also a scalar quantity. So kinetic energy is also scalar quantity. So in terms of its unit, so mass is measured in kg, velocity is meter per second. So its square is meter square per second square, which is equivalent to joule. So the unit of kinetic energy is also joule, as like work done. Now next thing is, if a body is stationary, then its velocity is 0, so kinetic energy is 0. So we can get only kinetic energy for moving object. Any non-moving object has 0 kinetic energy. Another thing is, mass is always positive quantity and v square is also positive. So as a whole, this right hand side is positive, so kinetic energy always positive. Never be negative, as like work done. So kinetic energy always positive or 0, depending upon it is in motion or there is no motion. Now, if there is a change of velocity of a moving object, then there should be a work done, which is called kinetic work energy theorem. So if there is change of energy, so whatever the change of energy, that is called work done. So in this case, half mv square is final kinetic energy, half mvi square is initial kinetic energy, where vi is initial velocity and vf is final velocity. Now the change in kinetic energy is final kinetic energy minus initial kinetic energy. If there is a difference, that is called total work done. Now there are three different situations. So the first one is, because we know that already, work done might be positive, negative, or 0. So if vf is greater than vi, so it means this one is, the first term is greater than second term. So total work done is positive. Yes, so it's positive. So its velocity is increasing. The situation, the example is, if you are applying force on a moving object along the same direction of motion, and its velocity keeps increasing. Just like this, if you accelerated a car on a highway, just pushing acceleration, and it keeps increasing its velocity. So in this case, the total work done is positive. Now second one is, if vf and vi are same, okay, vf and vi are same, that means there is no change of velocity, then total work done is 0. So there is no work done, no change of velocity, the body is moving the same velocity, then work done is 0. Now third case is, if vi is greater than vf, means the final velocity is less than initial velocity, then total work done is negative, less than 0. So in this case, the velocity, the body is slowing down. Just like if a body is moving on a frictional table, due to friction, the velocity goes on decreasing. So force and displacement are opposite to each other, so the work done is negative. So depending upon this work done is positive or negative, its velocity increases or decreases. If a work done is positive, then the velocity of an object keeps on increasing. If total work done is negative, then the speed or velocity of that object keeps decreasing. Or other case, if total work done is 0, and the body moves with same velocity or constant velocity.